All right, Hans had displayed this publication that NDSU Extension has put together on flax. Another one that I'd like to point out to you from Canada is from the Flax Council of Canada. And this is a publication called Growing Flax. And I've referred to it in the past. It has lots of details, and I think you'd find it a very useful reference if you retrieve it. And if you look at the website, there's likely other resources that might be of value to you. So I thought it'd be appropriate just to give an overview of flax production. That'll help tie in comments from Brian and Hans earlier, and then maybe we'll help tie in remarks from those speakers that follow. But I thought very simply, I'd just talk about some of the advantages of flax as part of the farm operation, and then certainly some challenges. So let's start with the pros. And that would be that it seems flax should be adapted throughout much of North Dakota, and we know it is. Certainly, if we have moderate temperatures and adequate moisture, that would certainly be a benefit for this crop that is this cool season crop. It seems to be adapted to a number of tillage systems, and but something that's not adapted to is salt. And Dr. Dave Franson will be talking about that during his presentation after break. It'll fit well in the crop rotation, in particular if you're looking for a non-legume broadleaf crop. Yeah, it certainly would be a consideration. No specialized production equipment is required as compared to maybe dry beans or even sunflower. Relatively low input costs. If you look at NDSU's budgets, you'll notice that the input costs are considerably less compared to a competing broadleaf such as soybean. However, when you look at the return to labor management, it is also less compared to soybean. In fact, at least in our region in East Central North Dakota, it's actually a negative number, but they're using very modest yields, and the prices are used in the budget are less compared to what current prices are. And so I believe in the budget, the market or the yield is around, I believe it's 18 bushel. And I hope with today's program, we're going to emphasize and help you push that yield much above that. And certainly that'll make the economics look better. Dr. Franson will talk about plant nutrition. This, in my view, it's rather simple. Sclerotinia tolerance is certainly something I think everyone identifies with versus our susceptible crops. And then another maybe minor benefit would be that the timing of harvest is oftentimes may complement small grain and should occur before our late season crop harvest, such as corn or sunflower. Might be some competition with soybean or dry bean, but you'll figure that out. And then some of the challenges are that it is in there for competition with other crops as we think about early planting priority. It's a basketball season now, and we want our cool season crops out on the court, and that includes flax. We don't want flax to be on the bench, and especially way down on the bench, as we consider priority in planting early season crops. So we want flax to be a starter, if you will, if we're going to have a chance of optimizing our yields. And Brian already talked about weed control. Certainly full season weed control is a challenge in flax because of the lack of complete canopy fill like we have with many other crops. And besides the lack of herbicides that are available compared to many other crops. And then harvest. Certainly harvest can be a challenge. Decisions have to be made based on uniformity of the crop in the field, based on the weeds that are present. Do we desiccate or not? If we do, we likely would be able to straight harvest. If we choose a swath because of weeds or lack of uniformity in a field, certainly we have swaths very susceptible to movement by wind. And so there's challenges. And so maybe a bit humorously, I put the question in, do you have sharp sickle blades? And really that's important no matter what harvest procedure you use. The straw or the stems are very difficult to cut. And then also, what do we do on post-harvest residue management? That's something that needs to be considered. So I took this picture a few years ago at Carrington, where we actually baled the residue and burnt it. And that's not uncommon in the state, but not that we recommend it, but just remember that residue management will be something to consider. I showed this nice table yesterday during our canola program. I thought it'd be good to show again today relating to flax. This is data from Manitoba, 7 years of data taken from commercial fields, and just showing the response of flax based on the prior crop. And as you can imagine, it performs very well following a number of grass crops, small grain crops, but also in this database has performed well with some of our broadleaf crops. Note soybean, and in particular, note the response by field pea. I guess I'm not sure how to explain that tremendous response, but at least this database certainly would encourage flax following field pea. And then on the other end of the spectrum, notice canola as a previous crop to flax. It's negative, and Dr. Franson will explain that during his presentation. So some general recommendations on establishing flax. And first, we've already talked a bit about seeding time. It is cool season in general. We like to see the crop planted as early as possible, as long as our soil conditions are appropriate. And we don't push things too hard on the earliness where we might have significant threats to the emerged plants to hard frost or very cold temperatures. So keep that in mind. One of the questions previously was relating to minimum and optimum temperatures for seeding flax or for flax emergence. I guess I'm not sure what the exact temperature is on the threshold for the seed to germinate, but I suspect it's right around 40 degrees. That'd be very close to what canola and small grain is, and so I think it'd be safe to say have that number in mind. Optimum, well, you can pick your number. My number would be 65 degrees. Probably would be very much optimum for very rapid emergence of flax. But is that realistic? Well, probably not if we're trying to plant early. We've alluded to planting depth already in previous talks. This year, especially if flax isn't planted as soon as possible, we might be concerned about where that soil moisture level is near the soil surface. And so there may be temptations to push the planting depth through maybe 1.5 inches or even deeper. So be careful about that. And then it seems like flax is left outside or in the cold when it comes to precision planting. So many of our crops, we talk about precise planting, in particular with row crops. And we're still talking about pounds per acre, which is okay. But more importantly is if we can talk about established stand on a per foot or per acre basis. And so we do know based on prior data that 70 plants per square foot would be ideal. But we also know with data to back this up that half of that many times will be quite satisfactory, especially if we're expecting modest yields, say in the 20s where we have opportunity for profitability. But if we would do all things right with the environment cooperating with us, and we have expectations to move into the 30s or even the 40s, such as in the northeast part of the state, well then it would seem like it'd be sound strategy to establish the density of plants beyond the 40 plants per square foot, maybe approaching somewhere between 40 and 70. Okay, I want to show you a little bit of data. Note that most of the data is rather old, but that's just the way it is. We just don't have a lot of production management work in the state on establishment, or as Brian alluded to, on weed management, and you'll see disease management. That'll be another example. But this is data from Minot, and it involved half a dozen flax varieties that were popular at that time. and notice very distinctly that planting early provided some yield benefits. As Hans talked about earlier, we want to have as full a bloom period as possible, and to have the bloom occur during moderate temperatures and where we have a better chance of having sufficient moisture to support the seed production. So planting early would be very advisable. This is some work from Manitoba showing flax seeding depth, and very simply, when they got beyond certainly 1.5 inches, we did see a decline in yield potential. And I guess I've planted flax trials of 1.5 inches, and it's come through quite well. But just be prepared for that as we possibly push our planting depth to reach the soil moisture. And then we've done some work in the past looking at interactions. This is an example where we looked at the interaction of seeding rates and nitrogen rates. The work was done at Carrington, Langdon, and at Minot, at research extension centers. And already this work is 2 decades old, but I think still applicable. I won't talk about the nitrogen part of it because Dr. Franson will discuss nitrogen, and also because we did not see a response to the various nitrogen rates we had in the study. But I will talk about the seeding rates, the subsequent stands, and ultimately yields. And so on the x-axis is the seeding rates that we were using, and then the gray bars are the subsequent stands that were established. And this, of course, is averaged over quite a number of site years. And so our stands that were established averaged from a low of 33 plants per square foot all the way up to 58. But in essentially all of the cases, we had modest yields. And when you look at the average, you see that there was no response as we increased the seeding rates and subsequent plant density. So in other words, the 20-pound rate that resulted in an average of 33 plants per square foot performed as well as higher rates and plant densities. I thought maybe it'd be good to show the plant lodging impact from seeding rates as well. And in this case, there was a very modest trend for increasing lodging, but for all practical purposes in the study and the environments that we worked with, increasing seeding rates had no impact on lodging. But be careful about this, especially under higher yielding environments. So in summary, we had difficulty, and we did not see a yield response with the rates that we used in environments that we conducted the study. And note again, it was more of a modest yielding environment from very low, 10 bushels all the way up to 27 bushels. And as I already mentioned, the 20-pound rate worked for us in this study, where it averaged 33 plants per square foot. And also note the range in the plant density amongst the site years, anywhere from a little over 20 to up to 45 plants per square foot. So certainly we have flexibility, and just adjust as best you can based on what you expect the season to hold, and in particular what the yield potential may be. So I've been talking about using old data. We do have some newer data that's being developed with the interaction of seeding date and rate, and this work is being done out in Williston. They've completed 2 years. It started in 2019, and they plan to continue the trial again in the upcoming season. And actually, hopefully, they'll continue it further into the future. A key part of this is that it is under no-till, and of course, in a semi-arid environment. And so I'll show you the preliminary data. This first graph is the seeding date information from 2019. And notice in this no-till environment that as the seeding date was delayed, there was a yield increase. And so that's certainly very contrary to what our general recommendations are. Well, how about last year in 2020? Well, the story was somewhat similar. The box indicates where the highest yield occurred, and that was in the mid part of May. So looking at the 2 years of data, it would appear in that environment, lower yield, lower moisture, and in no-till that delaying the planting until the last half of May may provide the best chance for optimizing yield. Well, how about the seeding rate? In 2019, when they hit 25 pounds per acre, that's when they started to optimize yield. This last year, in 2020, when they hit 25-pound seeding rate, that's where they began to have optimum yield. And so again, it'll be very nice to see continuing data coming in from the study before we make final recommendations in a no-till environment that's is modest yielding. So to wrap up, seed early, yes, please consider that. Although there's a question about a no-till environment where we have maybe more moisture conditions and cooler conditions as well. So the story will be told once the work is complete in Williston. We've talked about depth already. Just be careful about that if we're pushing things because of soil moisture levels. And then it appears that 25 to 45 pound continues to be a good range to plant flax. And if we can establish 30 to 40, our data continues to illustrate that seems to be a very good established stand density to have very adequate yields.